Welcome guys back to another of my YouTube video. Today my focus will be on solving some problems that may involve the use of Venn diagram. Word problems that I will be illustrating by way of Venn diagram. Remember now, if you have not yet subscribed to my channel, please do so now. Also remember to like, share, and subscribe. Now, I've already gone ahead and illustrated the problem on the board. It says, for the people were asked if they play volleyball or football. 25 as such were interviewed, indicated that they play football. 15 played volleyball. 5 both volleyball and football. 5 said neither volleyball nor football. We are asked here to display the information on a Venn diagram. It also asks how many played volleyball only, how many played just football, what percentage played just volleyball. So first, we are tasked with illustrating the information using a Venn diagram. So what I will do is to let those who represent are playing volleyball. So volleyball will be represented by the letter V. So I'm representing by the letter V, while football will be represented by the letter F. So first, guys, we need to construct our Venn diagram. Now we are using football and volleyball, therefore I will need 2 circles. They want how much played both, therefore there's an intersection. So volleyball, so I'm using 2 circles to represent here. Remember, it's not drawn to any particular scale. So volleyball will be V and football will be represented by the letter F. Now, as it indicated here, that 5 played volleyball and football. So it therefore means these 5 will be going in the intersection where volleyball overlaps football. It also stated that 5 of these were interviewed. They are not playing football and they are not playing volleyball. Therefore, those 5 are still a part of the universal set, which we will put on the outside. Now, the problem wants us to find how many played volleyball only and how many were only playing football. It therefore means that the section of the Venn diagram which represents volleyball only would be this section highlighted in green. The section which played football only would be this section that I am representing with blue. Remember already, guys, 5 of these persons are playing both sports. If I should, let me erase here. So in total, how many are playing volleyball? The problem tells us that in total, 15 are playing volleyball, which means that this 15 consists of also these 5. So in total, volleyball only would be 15, and I'm taking the 5 out because these 5s are already accounted for. Likewise, it's telling us that 25 are playing football Of that 25, we have already accounted for 5. Therefore, football only will be 25 take 5. So in a true sense, guys, 15 subtract or take 5, we are left with 10. 25 take 5, we are left with 20. Now, so the answer that we are looking for in terms of football only would be represented by this section here, which means that 20 played football only. Now, volleyball only would be so we are taking 15 take 5, we are left with 10. What else did the problem ask us for? So guys, we can always work to see whether or not we'd have gotten, remember in total there are 40 persons being interviewed. So we must account it for 40, so we can prove our answers. 10 is playing volleyball only, 20 is playing football, 10 and 20 give us 30. We have 5 playing both sports, so 30 plus 5 will give us 35. And we have 5 who are not playing volleyball or football, therefore 35 plus 5 is equal to 40. So we'd have accounted for all 40 in this Venn diagram. The next question is, what percentage played volleyball only? So in terms of percentage, we are looking at volleyball only, which would be 10 all over the total, which is 40 participants, and we multiply by 100. We can 0 here, 2 into 4 goes 2, 2 into 10 5, 2 to 2 1, 2 to 10 5. 5 times 5 will give us 25. So of that total amount, we can safely say that 25% of the participants are playing just volleyball. They are not playing any other sport. They are just playing volleyball. We now move to our second problem. It tells us that there are 24 students in a class. Of this 24, 12 are studying biology, 13 are doing physics, 4 students study not biology, not physics, neither of the two. The problem wants us to illustrate or show this information on a Venn diagram. It also asks us to find how many students are doing both subjects, how many students are studying just biology, and how many are focusing just on physics. So first, we must display on our Venn diagram. Not so accurate. Let me give it a better shot. So I will use letters to represent the two subjects being are the two areas of focus. So what I will do is B will represent biology, and we have P for physics. So first, it tells us that there are 4 students who are not looking or studying physics, and they are not doing biology. That's not their area of focus. So we'll keep these 4 on the outside of these two sets because they are part of the class or part of the universal set. Remember, the universal set consists of 24. It wants us to find how many students are doing physics and biology. That is not given, so we want to find that information. So what I'll do is to let B intersecting P be called X. So I'm using X to represent the intersection of both sets. So I'll place X here. It wants us to find biology only, which would be all of this area excluding the intersection would have been biology only. Therefore, how many students are focusing on biology? We know altogether there are 12. But of this 12, the X is also a part of this 12. So I'll subtract 12, take X. We'll go ahead and look at P as well. How many physics? There are 13 being accounted for by X value here. So I'll subtract this value, subtract X. So this is representing physics only, biology only. So what we can do is to use this bit of information now to create a linear equation. 12 minus X, this is positive, plus X plus 13 minus X plus, guys, we're accounting for this 4, all equal to 24. The universal set or the total amount being 24. Hence, what we'll do is to add our values. 12 plus 13 will give us 25, plus 4 will give us 29. Negative X and negative X will give us negative 2X plus X is all equal to 24. Therefore, 29 will take a positive and a negative. We do subtraction, keep the value of the greater absolute value. So we are left with negative X here is equal to 24. Therefore, negative X is equal to 24. Take 29. Negative X is equal to negative 5. Want the value to be positive, divide both sides by the coefficient, which is negative 1. Therefore, guys, we know that X is 5. So we can safely say that there are 5 students who are studying both subjects. So if we want an indicator of 5 here, that's cool. Now it asks us for biology only. So we'll do that. So biology only, guys, would be 12 minus X. And in this case, we know X to be 5 says 12, take 5, which will give us 7. So we know that can safely consider that 7 students are doing biology only. Again, we want to look at physics only. Well, physics only would be, as you can see, 13 take X, which would be 13 take 5, which will give us 8. So we can safely say then that 8 students would have studied just physics. And when we add our values, we should account for 24. So let us prove our answers. 7 plus 5 will give us 12. 12 plus 8 will give us 20. 20 plus 4 will give us 24. So we'd have actually demonstrated our information using the Venn diagram. We'd have solved for the intersection, which is 5 students doing both, and we'd have solved for each individual subject. In this case, biology have 7 students only, total of 12. 5 and 7 will give us 12. So 12 students really doing biology. And again, biology only, sorry, physics would be 13 takes x, 5 minus 13 takes 5, which will give us 8. So 8 students are only focusing on physics. Altogether, 5 and 8 give us 13 students who are actually studying physics. So we can go ahead and we'll work a third problem. On the board we have problem number 3. Says in a class of 50 students, 30 takes English, 23 take math, and 12 are doing both English and math. Now the information wants us to illustrate on the Venn diagram. Then it wants us to find, says, what is the probability that a random selected student take math, both math, English, does not take English, math but not English, math or English, neither math nor English, take math or English but not both. So first of all, guys, we need to illustrate this bit of information using a Venn diagram. Now, so first what I'll do is to have my Venn diagram, and I will let the letter E represent English and the letter M represent math for that set. So E for English, they overlap. I'm using M for math. So this will be my Venn diagram. It says 50 students in the class, 30 for English, and we know then, guys, that there are 12. So the given, the intersection, in other words, math intersecting English or E intersecting M is equal to 12. That's a given. Now they want us to, so what we'll do here is to find how many students going for English only, how many doing math only. So if we know that already 12 out of the 30 doing English, so obviously English only will be 30, take 12. So I think we have 18 students here. 23 are there for math already. We accounted for 12. So 12 from 23 will give us 11. So 23 take 12. We know that 11 students are doing math only. But what have you noticed with the Venn diagram? There are 50 students in the class. So we must account for all 50. So again, we said the universal is 50. Now, we must account for all students in the class. So the total class, we are thinking of 18 plus 12 plus 11. This will give us 18 and 12 will give us 30. And 11 will give us, this is 41, guys. So what happened to the other students? We have not yet accounted for 9 students. So we know 50 takes 41 will give us 9. So for sure, we know that there are 9 students here who are not doing English, and they're also not doing mathematics, but they are part of the entire class or the universal set. So we found out here then that in terms of E union M would be 9 students. Those are in the universal set. Now let us go straight to a question being asked. Now, what is the probability of a student taking mathematics? So we want to look at the probability of a student taking mathematics, guys. For probability is by chance, it's selecting at random. It's going to be in terms of a fraction. How many students we say take mathematics? How many students? It says that there are 23 students who take mathematics. So the probability of a student taking just math would be 23 over 50. Because it tells us that there are 23 students. So if I was to randomly select any one student, I can select at least 23 out of 50. Alright, so the probability of a student doing math, which is M, or some may see it being written as P. That's the probability of students doing math. Next, what about the probability of students doing both maths and English? Maths and English in this sense, I'm just going to erase this line here. Just answering the questions being asked. The intersection, both maths and English, is 12. How many students are in the class? So that will be 12 over 50. And if we were to simplify 12 over 50, that would result in 6 over 25. Does not take English or math. So look at it carefully. Does not take English. How many students does not take English, guys? So we have to look at these students who are not a part of English. So already we know that there is 11 here who are only doing math, and there are 9 that are not doing any of these subjects. So does not, so this would be 11 plus 9 all over universal set. So 11 plus 9 will give us 20 over 50, and we can simplify 20 over 50 can be simplified as 2 over 5, right? So 2 over 5 in terms of students not doing English. So we are looking at this 11 plus this 9. The next question is take math or English. So we are looking at how many students either take math or English. All these students either take maths or English. How many? 18 plus 12 plus 11. They are either doing this subject. So does not take English. I missed one here. Could be that. Math but not English. Okay, so I need to do this one here. Math but not English. So we look at those who are doing math but not English would be, I just write it here, guys. Math but not English. So let us just look at, so they are doing math but they are not doing English, and clearly we can see that there are 11 out of 50. So 11 out of 50 math but not English. The next one is how many, we are looking at the probability math but not English. So they are doing math but they are not doing English. Look carefully. They are doing math but they are not doing English. That's the one we just do. So math or English. So let us look at how many students are either doing math or they are either doing English. So we are looking at 18 plus 12 plus 11. So if I write this one here, so I think of 18 plus 12 plus 11 all over 50. We simplify where we can. That would be 41 over 50 students. 41 over 50. Note we are doing probabilities. And a fraction is choosing or selecting at random. The next one is neither math nor English, which means I will have to make some space on my board here. Neither math nor English. So, in other words, look to see how many students are not doing any of these two subjects. And for sure, it's 9 students standing alone. So 9 out of 50 students. And the last one is math or English, but not both. So math or English, but not both. So look at it, guys. Who is doing math here? So we have 18 here. Math or English. Not both. So we are looking at 18 students here doing just English. And we are looking at 11, which will give us 29 over 50. So that will be 29 over 50 students. So we have come to the end of this video and hope you would have learned something from my video. And remember to like, share, and most importantly, subscribe.